Hi there, welcome to edupediaworld.com. You're watching the videos on congruency. So in this video we'll discuss some more criteria for congruency. So what are the more criteria we can use to prove congruency, and some of the questions which are important from the exam point of view. You have to watch this video very carefully. So let's get started with the first topic, or we can say the first criteria for congruency. So Sss rule, also known as side, and side rule. In this rule, if three sides of one triangle are equal to three sides of another triangle, then the two triangles are congruent. So let me explain what this line is saying. So let's suppose we have two triangles, triangle A, B, C and triangle PQR. So let's say this side equals to this side, and this side equals to this side, and this side is equals to this side. So we can say that these two triangles are congruent by Sss rule. So what's Sss rule means? The three corresponding sides of two triangles should be equal and should reflect. Means let's say this side AB should be correspondence to side PQ, and these two sides should be equal. Similarly, side AC, which is corresponding to side PR in the triangle, so these should be equal. So this is how we can prove the Sss rule, congruency rule. So let's discuss the another rule. It's very important rule and widely used in congruency, so please listen it carefully. Now in RHS rule, in two right angle triangles, the hypotenuse and one side of a triangle are equal to the hypotenuse and one side of other triangle, then the two triangles are congruent. So what does means? So let's discuss first. Now let's say we have two right angle triangles like this, and we have another right angle triangle like this. Okay, now let's say this is triangle ABC, and let's say this is triangle PQR. So in RHS rule, so let me discuss first what is RHS rule. Students generally say this rule as right hand side, so which is not right hand side, which actually doesn't mean anything. So RHS rule means one angle should be right angle. Means in congruency rule we have three criteria to prove. So one criteria should be right angle, and another criteria should be hypotenuse, and the last criteria should be any side, corresponding side should be equal. So these three criteria come in RHS rule. So we have to be very careful while doing the RHS rule. So we have to look for one right angle and one hypotenuse and one corresponding side. Now so let's discuss how we can do this. So let's say in this triangle this is 90 degree and the corresponding angle this is 90 degree. So we have one criteria, and let's say side opposite to this right angle triangle, right angle is this, so this is hypotenuse. Similarly for this right angle, this is the hypotenuse side, so which is equal, then which should be equal to prove the congruency, and any other side can be equal. Either this side can be equals to this side, or this side can be equals to this side. So this is how we can prove and use the RHS rule to prove the congruency. So we have discussed two rules. One is Sss rule and another is RHS rule. So first we'll discuss some of the examples related to this rule, and then we'll do some questions which are very important from the exam point of view. So let's get started with the first example. Says that AB is a line segment. So AB is a line segment and P and Q are the points on the sides, opposite sides of AB, such that each of them is equidistant from point A and B. Now The example is AB is a line segment, so this is a line segment, and P and Q are the points on the opposite sides of AB such that it is equidistant from point A and B. Means this side equals to this side and this side equals to this side. We need to show that line PQ is perpendicular bisector of AB. Means we need to show that this angle is, each angle is 90 degree and this side should be equals to this side. So let's see how we can do this now. So first of all we need to write given. Okay. Now what is given is we have two triangles, and in these two triangles we can see that the sides are equal, so we can say that AP equals to PB, and we can say that AQ equals to BQ. Now so let's see how we can prove this first. So first in this question we need to consider triangle A, or we can see PAQ, and triangle PBQ. So we need to first consider two triangles, PAQ and PBQ. Okay, now so let's first prove these two triangle congruence, and then after let's see what we can get from these two triangles then. Okay, now so in this, we to prove these two triangle congruent we need three criteria. So let's see how we can find the three criteria then. Now so first is AP equals to PB, so which is given. Okay, then second criteria can be AQ equals to BQ, which is also given, and third can be PQ equals to PQ now, which is also given. So we have triangle, we can say PAQ is congruent to triangle PBQ. So by which rule? We can say Sss rule. So we have proved the two triangles congruent by Sss rule. Now so similarly we can say that now this two triangles, so let's say triangle APQ is equals to, we can say PBQ or BPQ. So by CPCT. Okay, so let me mark the angles first on the diagram so that you can see. So this angle equals to this angle, so by CPCT. Now we need to prove PQ is perpendicular bisector of side AB. So let's see how we can do this. Okay, now let's consider another two triangles. So triangle APC and triangle, we can say P or BPC. Now so let's see how we can prove these two triangles congruent then. Okay, now we have AP equals to PB. Okay, now and we have PC equals to PC, which is common. Okay, and AP equals to PB, which is also given, we can say that. And then we have one included angle, which is angle APQ equals to angle BPQ, which we have proved over here, we can say over here. So we have included angle and two sides, so this is a side and this is included angle and this is the another side. So we can say that triangle APC is congruent to triangle BPC by SAS rule. So we have proved the two triangles congruent by SAS rule. Now we can say that angle PCA equals to angle PCB by CPCT. So in the next part we have to prove that these two PQ is perpendicular bisector of AB now. And by CPCT also we can say that AC equals to BC by CPCT. Now, so let's consider line AB. So line AB is a straight line, and we know that angles on a straight line equals to 180 degree. So we can say that angle PCA plus angle PCB equals to 180 degree. So we can write, since angle PCA equals to angle PCB, so we can write 2 times angle PCA equals to 180 degree. So angle PCA equals to 90 degree. Similarly, we can say that angle PCB is also 90 degree. So we can say that now PQ is perpendicular bisector of line AB. Why? Because AC equals to BC, so it's equal, and each angle is 90 degree. So this is how we can prove these type of question. So let's discuss the next example, which is example number 2. So example says P is a point equidistance. So this point is equidistance from two lines L and M. So this side equals to this side, and intersecting at A. Show that line AP bisects the angle between them. Now we can clearly see that this angle and this angle is each 90 degree given. Now we need to show that AP bisects the angle between them. So we need to show that this angle equals to this angle. So let's see how we can do this. So first we need to write given. So what is given? BP equals to PC, and angle B and angle C is each 90 degree. So these are given. So we need to prove that AP bisects angle between them. Okay, now let's see how we can do this. Now we need to consider two triangles. So let's say triangle ABP and triangle ACP. Now we need to consider these two triangles. So let's see how we can prove this. So it's given that BP equals to PC, angle B equals to angle C. Why? So we can say that each 90 degree, and AP equals to AP, so which is common side. So we have three criteria, 1, 2 and 3. So we can say that triangle ABP is congruent to triangle ACP by RHS. So why RHS? Let's discuss this. So RHS means one should be right angle. So we have one right angle, and H means the hypotenuse should be equal. So if you see the triangle carefully, okay, now so this is angle B. So opposite to this 90, this is hypotenuse, and opposite to this is hypotenuse. So we have hypotenuse equals, since AP equals to AP, which is common, and any other side should be equal. So we have BP equals to PC, so which is also given. So we can say that these two triangles AB and ABP and ACP are congruent by RHS. Now so what we need to prove is AP bisects angle between them. So we can say that angle BAP is equals to angle, we can say CAP by CPCT. So congruent parts of congruent triangle. So these two triangles are equal by CPCT. So this is how we can prove these type of questions. So let's discuss the next question, which is question number 1. Okay, now this is very important questions, and I have seen these type of questions generally coming in examination. So you have to watch this part of a video very carefully. Okay, now it's given that triangle ABC. Okay, now This is very important questions, and I have seen these type of questions generally coming in examination. So you have to watch this part of a video very carefully. Okay, now it's given that triangle ABC and triangle DBC are the two isosceles triangles on the same base BC and the vertices A and D on the same side BC. If AD is extended to intersect BC at P, we need to prove these four parts. So let's discuss how we can do this. Now, first of all, we need to write what is given. It's given that triangle ABC and triangle DBC are congruent. So we can say that AB equals to AC and BD equals to DC, since opposite sides of isosceles triangle are equal. So this equals to this and this equals to this. Now, so this is given. So let's see how we can prove this. Now, to prove, now, so let's prove the first part. The first part we need to prove is triangle ABD is congruent to triangle ACD. So let's discuss how we can do this. Now, ABD, this triangle, and ACD, so this is a triangle. So let me draw the triangle over here, or we can do it directly. That doesn't matter anyways. Okay, now, so it's given that AB equals to AC, which is given. Now, and second, we can say that BD, or we can say that BD equals to DC, which is also given, and AD equals to AD, which we can say that it's common. So we have three criteria. So we can say that triangle ABD is congruent to triangle ACD by Sss rule. So these two triangles are congruent by Sss rule. Now, so we can say that by CPCT this angle equals to this angle, or we can say that angle BAP or BAD is equals to angle CAD by CPCT. So these two angles are equal by CPCT. Okay, so we have proved the first part. Now, the next part is we need to prove triangle ABP is congruent to triangle ACP. So ABP, so this complete triangle, let me draw with another pen then. Okay, so this complete triangle we need to prove ABP and ACP. So this is a triangle we need to prove. So let's see how we can do this now. First of all, we have AB equals to AC. Again, it's given. Okay, then now we need the second criteria. We can say that, let's say AP equals to AP, which is common. Okay, now for third criteria, we have already said that BAD, angle BAD equals to angle CAD by CPCT. So we can say that angle BAD equals to angle CAD by CPCT, or we can say that proved above. So we can say that triangle ABP is congruent to triangle ACP by SAS. Okay, and then for further we can say that BP equals to PC by CPCT. Okay, so this is how we can prove the second part. Now, so let's discuss the third part. The third part says that we need to prove that AP bisects angle A as well as angle D. So we need to see that how we can do this. Now, AP bisects angle A we have already done over here, since angle BAD equals to angle CAD by CPCT. So now we need to prove that this angle equals to this angle. So let's see how we can do this. So let's consider now two triangles, triangle BDP and triangle CDP. Now in this triangle we can say that BD equals to DC. It's given, okay, and we can, third condition, we can say that DP equals to DP, it's common side, and we can say that BP equals to PC. We have proved above, isn't it? We have proved over here. BP equals to PC. We have proved over here. So we can say that triangle BDP is congruent to triangle CDP. So we can say that by CPCT, angle BDP is equals to angle CDP by CPCT, and we have proved these two triangles congruent by SS. So this is how we can use the different questions the way SS and RHS rule. Now, so the last part says we need to prove that AP is the perpendicular bisector of BC. Now we need to prove that. So let's see how we can prove this. So we already know that triangle BDP is congruent to triangle CDP. We have already proved, isn't it? Now, so we can say that angle BPD is equals to angle CPD by CPCT. Since BC is a straight line, so we can say that angle BPD plus angle CPD equals to 180 degree. And since angle BPD equals to angle CPD, so we can say that 2 times angle BPD equals to 180 degree, and this implies is angle BPD equals to 90 degree. So we can say that now, since angle CPD is also 90 degree, so we can say that now AP is the perpendicular bisector of BC. So this is how we can prove these type of questions. Okay, now let's discuss the next question. Now this is also very important question. Okay, now so question is, AD is an altitude of an isosceles triangle ABC in which AB equals to AC. We need to show that AD bisects BC and AD bisects angle A. So it's very simple question. So let's discuss it quickly. It's given that ABC is an isosceles triangle, so AB equals to AC, and AD is an altitude of triangle ABC. Now let's see how we can do this. So we need to prove, first part is AD bisects BC. So let's see how we can do this now. So let's first draw the diagram for this. So let's say this, we have triangle ABC and AD is an altitude. So let's see how we can do this, and it's given AB equals to AC. So you can say consider triangle ABD and triangle ACD. So let's say how we can do this. Now in this, it's given AB equals to AC, it's given, and we can say AD equals to AD common side, and we can say that since AD is altitude, so each angle is 90 degree. Okay, so we can say that angle ADB equals to angle ADC, each 90 degree. So we can say that triangle ABD is congruent to triangle ACD by RHS. So why RHS? Since we have one right angle, so this is right angle and this is hypotenuse, so these two hypotenuse are equal, and one common side, any other sides are equal. So these two triangles are congruent by RHS. So we can say that BD equals to DC by CPCT. So we can say that now AD bisects BC. Now, so second part says that AD bisects angle A. So again we can prove it through CPCT, since two triangles ABD and ACD are congruent. So we can say that angle BAD is equals to angle CAD by CPCT. Okay, so this is how we can prove these type of questions. So let's move on to the next question. Now the question said two sides AB and ABC and median AM of one triangle ABC are respectively equal to the sides PQ and QR and median PN of triangle PQR. So we need to prove these parts. So let's say how we can do this. So it's given that first of all AB is equals to PQ and AM equals to PN and BM equals to Q1, and AM and PN are medians, right? So let's see how we can prove this. So we need to prove, first part is to prove triangle ABM is congruent to triangle PQN. So these two triangles are congruent. So let's see how we can prove this. So we have AB equals to PQ, so it's given, and next is BM equals to Qn, which is also given, and AM equals to Pn, which is also given. So we have triangle ABM congruent to triangle PQN by Ss rule. So why? Because three sides, corresponding sides are equal. So these two triangles are congruent by SSS. So this is how we can prove the first part. Now let's discuss the second part. The second part says that we need to prove that triangle ABC is congruent to triangle PQR. Okay, now, so before doing this part, so let's say how we can prove this. So we can say that angle B equals to angle, we can say Q by CPCT. Since these two triangles are congruent, so we can say that by correspondency. So these two angles are also equal. Okay, now let's say how we can prove this. So it's given that AB equals to PQ. Okay, so it's given now, and since BM equals to QN, it's given. Since AM and PN are median, so we can say that BM equals to MC and QN equals to NR, isn't it? So we can write BM as half of BC and QN can be written as half of QR. So this get cancelled. So we can say that BC equals to QR. Okay, now, and then we have angle B equals to angle Q, which is proved. So we can say that now triangle ABC is congruent to triangle PQR by SAS rule. So this is how we can prove these two triangles are congruent. So this is how we can use the congruency to solve the problem. So let's discuss the next question of the video. It's very important question also, so you need to watch this question very carefully. So it's given BE and CF are the two equal altitudes of triangle ABC. So we need to use the congruency RHS to prove that triangle ABC is an isosceles triangle. Okay, so let's first draw the diagram. So we have triangle ABC and we have altitude E, and from C we have an altitude F. So let's say this is 90 and this is 90. So using congruency we need to prove. So let's say how we can prove this. So this is an isosceles triangle. So first of all, let's write what is given. It's given that BE and CF are equal altitudes. Okay, now, and okay, so need to prove ABC is an isosceles triangle. Okay, now, so let's consider two triangles. Triangle, you can say BEC, and triangle, we can say have triangle BEC and triangle CFB. Okay, so in this triangle we can say that BC equals to BC, it's common, and we can say that angle E equals to angle F, each 90 degree. Okay, so it is, sorry, it's 90 degree. Okay, and it's given that BE equals to CF, they are equal altitudes. So we have three criteria, 1, 2 and 3. Okay, so we can say that triangle BEC is congruent to triangle CFB by RHS. So why RHS? One is 90 degree, so we have one angle as 90 degree, and hypotenuse are equal. So let's say how. Okay, now, so hypotenuse to this 90 degree angle is this one, and hypotenuse to this 90 degree angle is also this one. So which is BC, which is common side, which is equal, and we have BE equals to CF. Altitudes given, they are equal, it's given. We can write over here, these are given equal. So these two triangles are congruent by RHS. Now, so let's say how we can prove this triangle as isosceles triangle. So these two triangles are equal, so we can say that angle B equals to angle C by CPCT. Okay, now, so this means this, we can prove that this angle equals to this angle. So we can say that now AB equals to AC. You can say that sides opposite to equal angles are equal. So we can say that now triangle ABC is an isosceles triangle. So why it's isosceles triangle? Since AB equals to AC. So this is how we can prove these type of question. So this was the last question of the video. Thank you for watching the video on edupediaworld.com. Keep watching further videos. So these videos will actually help you in the exams, how we can solve the questions related to congruency. So keep watching further videos. Have a nice day ahead.